Hi folks, I'm Chuck Black and we're doing 52 weeks of Python in 10-minute sessions. Today's topic is sets. Sets is a data type that I have not used all that much in real world situations, but it can be useful in certain instances, and so it's useful to learn about it since we've learned about other data types as well. I've written some code where we have IP addresses which are either available or used, and they're stored in sets, as you can see here. And we will be looking at the code and describing what sets are in general. So let's get started. We've learned about the major data types in Python. So we've learned about the major data types in Python, such as lists and dictionaries, and more recently we learned about tuples. The fourth major data type is a set. Now a set is basically going to be a collection of items. This collection is going to be identified by curly braces at either end when you see it printed out. Now you're going to say, wait a minute, isn't that what a dictionary does? Yes, it's what a dictionary does, but notice there's not a key value pair, there's just a value. And so this is going to be a collection of values. One unique thing about sets is that there won't ever be any duplicates. So you can try to add 10.0.1.195 to this set and it won't allow you to do so because you can't have any duplicates. So that is one unique attribute. The main use of sets is for checking for inclusion. So you find out if something is in a set or is not in a set. If you go further with sets, you can do things like intersection of two sets and union and things of that nature, but in my experience, I haven't used that all that much. So in our example, our code, we're going to look at inclusion dealing with IP addresses. That's what we'll look at next. So let's jump right into the code that I've written to demonstrate sets. Now what I'm doing is I have two different variables that are sets. One is called available IPs and one is called used IPs. So these are going to be IP addresses. The ones that are available for passing out are going to be in the available IPs, and the ones that have been allocated are in the set called used IPs. Now I have a function here called print IPs. All it does is print out the available and the used ones. Notice this is using an F string. Don't get confused by these curly braces. Remember, with F strings, curly braces denote that there's a variable inside. It has nothing to do with the fact that this is a set or any other data type. Now down here is my main code. You may say, well, wait just a minute. Don't you normally do something like this if name equals main in the main program? And you know what? You're exactly right. So let's go ahead and fix that. Okay, now I have my if name equals main, and this will only run if this is the main program. Makes it a little bit clearer and easier to see. So here I'm just printing the IP addresses. What does my code do? The first thing that I do is I'm going to create a set. Well, I have created the set already, but I'm going to add to the set 10.0.1. whatever this number is, and I happen to be creating these IP addresses between 180 and 200 with a hop count of 3. So that means I'll have 180, 183, 186, etc. in my available IPs. I'll print them out, then I'll go through this loop, and all I'm going to do is say, hey, give me an IP address. And if the IP address is not, if I don't give anything as an IP address, I'm going to exit. But if I do give an IP address, then I'm going to check to see if the IP address is in the available IPs. This is the main test that we do with sets. We're testing for inclusion. So I'm going to check that input IP address against my set, which is the available IPs. And if it's in there, then what I'm going to do is basically I'm going to remove it from available IPs. I'm going to add it to used IPs, and then I'm going to print them out. One thing to point out here at the end is I'm doing this check just to demonstrate this intersection. What I'm doing is I'm saying if available IPs and the intersection of that with used IPs is greater than 0. In other words, if we have more that if we have an IP address that's in both used and available, that would be an error. Now I should never hit this, but this is how you would do an intersection. And down here, if IP address wasn't in the available IPs, I just print it out. So let's run it and see what happens. So here I am running my sets program. It's asking me enter IP address to allocate. Because I'm lazy, I'm going to copy this and then I'm going to paste it. And let's see what happens. Okay, so here at the end, it says I've allocated the IP address 10.0.1.180, and you can see in used IPs, it's now appearing and it's not appearing up here. So what I'll do is I'll choose another one. Yeah, I'll do this 186 and come down here and allocate it. And at this point in time, you can see 186 is down here. It's been added to used IPs and it's not up here. And if I were to just to show that the code works, if I was to try to allocate this again, then it should give me an error. Yes, IP address not found in available IPs. So just to review, sets, it is the fourth data type, or more precisely collection type in Python that we've looked at. It basically is delineated by these curly braces. It's differentiated from dictionaries because there's only one item in each of these. In dictionaries, remember, we have key and value. Here we just effectively have a key. And the unique thing about sets is that you cannot have duplicates. So if you try to add something that already exists, then it just won't add it because it already exists. It's useful for testing for inclusion. So in our example, we found out if an IP address was available, and if it was, we allocated it into the used IPs. And if it wasn't available, then we did an error of some type. Here's an example where I am allocating 10.0.1.186, and you can see it has appeared down here. So some of the interesting things we do to do testing for inclusion. You can also do things like intersection, union, etc. But yeah, so that is sets. Hopefully that makes sense, and thank you for listening.